It's November 24th. I wanted to do a presentation on the double slit experiment that Thomas Young performed back in 1801 to begin the wave theory concept, the Young's double slit experiment. So you have a barrier with two slits in it and a screen beyond, and you shoot electrons through those two slits in the barrier and see where the electrons land on the screen behind. And what you find is that they make a pattern that spreads out over the screen, not just exactly behind where the slits are. The pattern that's up on the screen from the electrons being shot through the slits, that pattern is known as an interference pattern, and it's a waveform. Uh, yeah. Um, so if you send a wave of water through the same barrier with the two slits, instead of electrons, you'd see the same interference pattern. So why does a particle behave like a wave? How can a particle be a wave? You have to give up on the idea of particles. Start to deal with the reality that everything's a wave around you, a frequency. Nikola Tesla said uh, something along the lines, if you look into frequency and vibration, you have the secrets of the universe unlocked. So Erwin Schrödinger also redid the double slit experiment later on. I can't remember the date. And then Max Bohr also did something when Schrödinger did it. He came up with a math equation that was known as Schrödinger's equation. It was a wave equation that kind of explained this behavior, but not really. It kind of just like his idea was the electrons passed through that barrier, the slits, and when they did, they just kind of, I guess, got squished and smeared and spread out into that wave pattern on the screen, which is pretty like loose. Like that doesn't explain anything to me. Max Bohr did a better job. He had a probability wave where the particles were shown as a wave. So if you go back and think about all this stuff, you'll start to make some realizations. The first is that latent matter can behave both as a wave and particle, depending on whether or not it's being observed. So, how can a single thing behave like opposite actions at the same time? You shoot a particle, but you get a wave on the screen once it goes through the slits. But that depends on whether or not it's being observed. So if you shoot an electron, shoot one electron at a time, and place a detector by the two slits to see how the single electron can behave like a wave, then the pattern on the screen becomes the pattern of two strips, and the interference pattern disappears. The wave pattern goes away and it starts behaving like a particle when you look at it. Yeah. It was a wave until you observe what it's going to do, and then it acts like a particle. So, by looking at the electron, it's as if it knows it's being watched and behaves like a good little particle and does not behave like a wave. This means that by the act of observing and measuring electrons, the observation has a gigantic effect on the way the particle behaves. How does the electron know it's being observed? And how can the electron change its behavior depending on whether or not it is being watched? That's a double slit experiment. I tried to make it easy. It's pretty mind boggling, so go through it slow, think about it. It's pretty fun to think about, but yeah, that's our reality. So hope you enjoyed it. God bless.